We are now moving into the final section of the lecture. This is where we summarize the major ideas from the week and identify the technical concepts you should remember for later topics such as petrophysics, logging, and reservoir engineering. This slide summarizes two big ideas. First, there are 6 stages in the life cycle of a producing oil or gas field: exploration, appraisal or delineation, development, plateau, decline, and abandonment. Second, the slide reviews drilling rig categories, including cable tool rigs, rotary rigs, top drive rigs, jackups, semi-submersibles, drillships, and fixed production platforms. These are core concepts that help students understand when and where different drilling systems are used. This slide summarizes the 5 major systems on a modern rotary rig: power, hoisting, circulation, rotary, and well control. It also reviews the main components of the circulation system, such as mud pits, mud pumps, swivel, drill string, shale shaker, desander, desilter, and degasser. The slide also introduces major drilling fluid types, including water-based mud, oil-based mud, foams, and air. This is a very important consolidation slide because it links equipment to drilling fluid behavior. This is one of the most technically important summary slides. It explains why drilling fluid is so critical. Drilling mud lifts and suspends cuttings, stabilizes the borehole, controls formation pressure, deposits filter cake, minimizes reservoir damage, cools and lubricates the bit, transmits pressure signals for LWD and MWD tools, and helps minimize environmental impact. This slide is extremely important because drilling fluid is involved in almost every major drilling function. This slide summarizes 2 topics. First, it lists 3 major bit types used in the drilling industry: milled tooth tricone, insert tricone, and fixed cutter bit. Second, it reviews the well control system, including the accumulator and blowout preventer. It also explains that the mud system helps prevent kicks, while the BOP helps control a kick if one occurs. This is a very practical slide because it combines penetration mechanics and safety control. A kick is an unwanted but controllable entry of formation fluid into the wellbore. A blowout is the uncontrollable and catastrophic version of that event. This distinction is crucial. A kick is a warning condition that still allows intervention. A blowout represents a loss of well control with potentially severe consequences, especially because hydrocarbons may ignite. This slide lists the major causes of kicks. These include insufficient mud weight, improper mud replacement during tripping, swabbing, cut mud, and lost circulation. The common theme is that the wellbore pressure becomes too low relative to formation pressure, allowing formation fluids to enter the well. This slide is essential for teaching students how drilling safety is directly linked to pressure management. This slide lists warning signs of a kick. Primary indicators include increased mud return flow at constant pump rate, rising pit volume, continued flow after pumps are shut off, and improper fill-up during trips. Secondary indicators include pump pressure decrease, pump stroke increase, change in apparent weight on bit, drill break, bit drop, and reduction in mud weight. This is one of the most operationally important slides because early kick detection can prevent escalation into a blowout. This slide previews the next topic, petrophysics in core analysis. This is a very logical next step. After drilling a well, the next question becomes, what did we drill into? And how do we measure reservoir properties such as porosity, permeability, saturation, and lithology? So next week builds directly on this week's drilling concepts. Thank you very much for your attention. This week, we studied the role of drilling engineering across the field life cycle, major rig types, rig systems, the drilling process, and key safety concepts such as well control and kicks. These are foundational topics in petroleum engineering because drilling is the bridge between subsurface knowledge and actual field execution.